Hi learners. Now I am going to be talking about descriptive statistics and its types. Descriptive statistics are brief descriptive coefficients that summarize a given data sets, which can be either a representation of entire or a sample of populations. Descriptive statistics are broken down into measures of center tendencies and measures of variability. Measures of center tendency include the mean, median, and mode, while measures of variability include standard deviations, variance, the minimum and maximum variables, and the kurtosis and the skewness. Descriptive statistics allows us to characterize our data based on its properties. Generally, there are four major types of descriptive statistics. The first one is measures of frequency. It consists of count, percent, and frequency. It shows how often something occurs, and it is used this when we want to show how often a response is. The second type is called measures of center tendency. It consists of mean, median, and mode. It locates the distributions by various points, and it's used this when we want to show how an average or most commonly indicated responses. The third type is measures of dispersion or variations. It consists of range, variance, and standard deviations. It identifies the spread of scores by stating intervals. It's used this when we want to show how spread out the data are. It is helpful to know when our data are so spread out that it affects the mean. The fourth type is measures of positions. It consists of percentile rank and quartile ranks. It describes how scores fall in relations to one another. Relies on standard scores, and it's used this when we need to compare the scores to a normalized scores. For example, Naction norm. Normally, in the descriptive types, we typically interested in asking a four types of questions. The questions are as follows. The question number one: what is the center of the data? So for this, we have to get the conclusions or get the findings as a result of measures of center tendency. Therefore, I am highlighting and mean and median in these slides. So for finding the measures of center tendency, we need to go the three important calculations like mean, median, mode. First of all, we must know what is measures of center tendency. A measure of center tendency is a single value that attempts to describe a set of data by identifying the central positions within that set of data. As such, measures of center tendency are sometimes called measures of central locations. In this, first I'm going to be emphasize what is mean. The mean or average is the most popular and well-known measures of center tendency. It can be used with the both discrete and continuous data too. Although it is used most often with the continuous data, the mean is equal to the sum of all the values in the data sets divided by the number of values in the data sets. So, if you have the n values in a data sets and they have the values like x1, x2, and so on up to xn, the sample mean usually denoted by x bar is x1 plus x2 plus x3 and to xn divided by n. This is the formula for mean. The formula is usually written slightly different manner using a Greek capital letter sigma pronounced as sigma, which is means sum of. Normally we use the term as a sum of or summary. The formula for the mean, finally I may conclude, finally I may emphasize the formula for mean is x bar is equal to summation of x divided by n. Now I am moving to the median. Median denotes the most central values of the series of numbers. The median is the midpoint of the distributions. The same number of the scores is above the median is below it. The median is the middle score for a set of data that has been arranged in order of magnitude. The median is less affected by the outliers and skew data. The value which divided the values into two equal halves, with the half of the values being lower than the median and half higher than the median. The median formula for the ungrouped data is nothing but n plus 1 divided by the truth item. N is called as a number of items. If you want to find out the median, the continuous data, we have to adopt the difference formula. The formula is L plus n by 2 minus CFB divided by FW into I. So where L is equal to exact lower limit of the median class, n represents the frequency, total number of frequency, CFB represents cumulative frequency which is below the median classes, and FW in the formula is refers frequency within the median class, I refers size of the class interval. So therefore I am giving the small hint as a middle value of the distribution as a median. Now I am moving to the mode. The mode is the most frequently occurring score or most repeated value. The term mode has come from the French, in which it means to be patient. As a statistical language, mode is the value that occurs more or most frequently in a statistical distributions. So therefore I emphasize the term mode is called most frequent value or most occurring values. The formula to find out the mode for the continuous data or in a discrete data, we have to use the formula mode is equal to 3 times of median minus 2 times of mean. So this is the first question we are discussing. The first question is talking about what is the center of the data. So for this, we must know the 3 important things of methods of center tendency: mean, median and mode. The second question about the descriptive statistics is how spread out the data. It is the second question. From the second question, for the getting the answer for the second question, we have to look on the measures of variability. That's why I'm using the term QD and DST is nothing but quartile deviation, standard deviations. Before going to the one by one of the variability, first I'm going to highlight what is the measures of variability as well as the measures of dispersion. Variability refers to the extent to which the scores of the distribution differ from each other. And equivalent definitions says that the variability refers to the extent to which the scores in the distribution differ from the mean. If a distribution is lacking the variability, we may say that it is a homogeneous. Suppose if it comes an opposite, the data spread is called, or the data it may be heterogeneous. The extent or degree to which the data tend to spread around the average is called the dispersions or variations. Measures of dispersion help us studying the extent to which observation are scattered around the average or the center value. Normally, the measures of center tendency consist of the 4 important things. One is called range, average deviation, standard deviation, as well as the quartile deviations. We will discuss one by one. The first one I am going to be highlight what is range. Range is given by the highest score in the distributions minus the lowest score of the series. Range is the difference or the interval between the largest and smallest item. Symbolically, may written as a range is called the highest score minus lowest score. Now I am moving to the mean deviation. Sometimes we may call as an average deviation too. Average deviation is defined as the average distance of the scores from the mean of the distributions. It is also called as a mean distribution or MD. To find out the average deviations, to account is taken of signs, and all the deviation, whether plus or minus, are treated as a positive. Average deviation is one of the measures of dispersion dealing with all items. Measure of deviation is an average of the deviation from all the individuals of scores from their mean. For find out the calculation for average deviation for the ungrouped data, the formula is summation of modulus of small x divided by n, where small x is called a capital X minus m, is nothing but the deviation of the raw score from the mean. N here refers number of scores. If you want to find out the average deviation for the continuous data or a group data as a group data, we have to use the different formula, that is called mean deviation is called summation of modulus f into small x divided by capital N, where small x is equal to capital X minus M, is nothing but deviation of the row scores from the mean. The third of the measures of variability, I am going to highlight what is standard deviations. The standard deviation was first introduced by Carl Pearson. It provides a standard unit for measuring the distance of various scores from their mean. Standard deviation, the most stable index of variability, is denoted usually by the letter sigma, the Greek letter alphabet. The standard deviation is defined as a positive square root of the arithmetic mean of the scores of the deviations of the observation from the arithmetic mean. The value of the SD is always a positive. Standard deviation is the square root of the mean of the squares of the deviation of integer items from the arithmetic mean. So here I may highlight the two important formulas of the standard deviation. The one formula for raw data, other formula for the group data. For the raw data formula, SD is equal to root of summation small x square divided by n. Here the small x is nothing but capital X minus M. The same way, if you want to find out the standard deviation for the group data, we have to adopt another formula, that is called root of summation f into small x square divided by n. Now I move to the quartile deviations. Sometimes we may call as a interquartile range too. Interquartile range includes the distributions. In other words, interquartile range is the difference between the third quartile and the first quartile. Normally the interquartile range is equal to Q3 minus Q1. Quartile deviations or QD can be defined as a half of the difference between the 75th percentile and the 25th percentile. Hence, it's one half of the scale's distance between the 75th and 25th percentile in frequency distributions. The formula for QD is equal to Q3 minus Q1 divided by 2. If you want to find out our computation the quartile deviation from the group ungroup data or the raw data, we have to use the formula, the same formula we have to use. But for finding the Q3 and Q1, we have to use a different formula. If you want to find out the value of the Q1 in the raw data, we have to use the formula n plus 1 divided by fourth item or fourth score. For finding the Q3 value, we have to use the formula 3 times of n plus 1 divided by fourth item or score. The same way, if you want to find out the Q3 and Q1 value of the group data, we have to use the different formula. For finding the Q1 is equal to L1 plus n by 4 minus CFB divided by FW into I. If you want to find out the Q3 value, we have to use the different formula. It's nothing but L3 plus 3n by 4 minus CFB3 divided by FW3 into I. So if you use this formula, we may find out the value of Q3, Q1. Then finally we may substitute the value into QD. We may get the QD value. Yes, so now we are discussing about the two important questions. Now I move to the third questions about the descriptive statistics. The third questions talk about what are the extremes of the data. If you want to find out the extremes of the data, we have to find out these three things. One is called minimum, maximum and outliers. Maximum score and minimum score is nothing but the lowest score of the data as well as the highest score of the data. Then outliers, some of the scores, only few of the scores may be scattered in different places. Most of the scores be scattered around the average only, but only few of the scores, if they lies on the different places, then we may call as the terms outliers. So I hope we are discussing the three important questions about the descriptive statistics. I hope you understand. Now I'm going to the last questions. What is the shape of the distribution? Is it symmetric or asymmetric? Based on this only we have to go for inference statistics. For if we find out the answer for this question only, we have to adopt whether we can go with the parametric or non-parametric statistics. For finding the shape of the distributions, we have to think about the three important shapes. One is called normal probability curve, skewness and kurtosis. For this question, I am going to emphasize the three important diagram based representation of the important things I am going to talk about now. One is called normal probability curve. Normal probability curve is also called as a normal distributions. Normal distribution is the cornerstone of the modern statistics. which is highly useful in statistics and is need to deal with continuous probability distributions. The normal distribution was first discovered by De Moivre in 1733 to solve problems in games or chances. Later, it was applied in natural and social science by the French mathematicians Laplace. This concept further developed by the Gauss. The literal meaning of the term normal is an average. Now I'm going to emphasize some of the properties of the normal property curve. The first property is talking about the bell-shaped curve. So the shape of the normal curve is like a bell shape. The second property, mean equal to median equal to mode. It means that the value of the mean, median, mode are same. It's nothing but the three values may fall at the same point on the curve. The third property is called as a unimodal or unimode. The curve starts and reaches the peak in one point and slows down. So the curve is having only one mode, it means. Then the fourth property is perfectly symmetric. The normal curve is perfectly symmetric in nature. That means the curve inclines towards both sides equally from the center of the curve. Thus we get equal halves on both sides from the center point. The fifth property is called not skewed. It means that the curve is not skewed. It means that the value of the measures of skewness is equal to 0. In this case of normal property curve, the skewness value is equal to 0. The next property is called asymptotic. The normal curve does not touch on the base or the x-axis on the both sides. Thus, it extends from negative minus infinity to positive or plus infinity. The next property, we may highlight some of the various measures of the normal property curve. In the normal property curve, the quarter deviation value, it may be 0.6745 approximate value. The mean deviation value 0.7979 approximate. The skewness value we already discussed is exactly 0. The kurtosis value is equal to 0.263. These are some of the measures of the normal property curve. The next property, distance of the curve. For practical purpose, the baseline of the curve is divided into 6 sigma distance from minus 3 sigma to plus 3 sigma. Most of the cases, that is 99.73% is covered within the such distances, within the plus or minus 3 sigma region. The next important property, this is called 68, 95 and 99.7 rule. What it means? It means that the distance of the curve from minus 3 sigma to plus 3 sigma is equal to 99.73%. The distance of the curve from the minus 2 sigma to plus 2 sigma is 95.44%. The distance of the curve from minus 1 sigma to plus 1 sigma is 68.26%. Therefore, we are using the rule as a 68, 95, 99.7 rule. The next property, maximum ordinate of the curve. The maximum of the curve occurs at the mean where z1 equal to 0 and the value of the highest ordinate is 0.3989. The highest of the ordinate at 1 sigma is 0.2420. The 2 sigma is 0.0540 and the 3 sigma value is 0.0044 respectively. The analysis of the scale value, the next property, the scale values are analyzed as z1 is equal to x minus m divided by sigma is nothing but the score, integer score minus mean divided by the standard deviations. One point of inflections. The point of inflection is each plus or minus 1 sigma. From above and below the means the curve changes from convex to concave at this point with the baselines. I hope you understand the normal property curve and its properties. Now, for finding the answer for the fourth question of us, what is the shapes, we can think about some of the asymmetric things also. Normally, this normal property curve is called as a symmetric curve, but if you other than the normality, then we may use the term as asymmetrical. That things we may discuss now. That is called skewness. Other one is called kurtosis. Normally, the skewness is called as a deviation from the normality. The skewness means asymmetrical natures. The degree of the departure from the symmetry is called skewness. The distributions in which mean, median and mode fall on different points or different places is also known as skewed distribution, and the tendency of the distribution is known as skewness. The skewness of the distributions can be two types, which gives the birth of two types of curves. One is called positive skew, other one is called negative skews. So in this diagram, it focuses on the three things. One is called normal, the center is called, the B diagram is normal, the left one is called negative skew, the right one is called positive skew. So I'm going to define what is the positive skew first. When the curve inclines more towards right, we ascertain the positive skewness. The distribution in which most of the frequency are concentrated in the class interval bearing lower values is known as a positive skew distributions, and the curve obtained from the distribution is called the positive skew curve. Positive skewed or is skewed to the right because the scores tend or trail off to the right or the positive end of the curve. If the longer tail of the distribution is towards the higher values or upper sides, the skewness is positive. Now next I move to the negative skew. When the curve inclines more to the left, skewness becomes negative. The distribution in which most of the frequencies or scores are concentrated in the class intervals of higher values as negative distributions, and the graph drawn on the basis of the distributions is called negative skewed of the curve. Negatively skewed or skewed to the left because the scores tend to trail off or left or the negative end of the curve. If the longer trail of the distribution is towards the lower values of the lower slides, the skewness is negative. So I hope you understand the meaning of skewness. Here I may emphasize, I may highlight the three formulas of the skewness value. Skewness, how we can find the skewness. If you know the value of mean and median as well as the standard deviation. If you know the value of Q3 and Q1 as well as the Q2, how we can find out the skewness. There is a three formula I discussed in these pages. Now I move to the last shapes. This is also normality. Division from the normality, that's other than the kurtosis. The kurtosis of the distributions refer to its curveness or peakness. The distributions may have the same mean and the same variance and may have equally skewed, but one of them may be more peaked than the other. Kurtosis refers to peakness or flatness of the normal curve. The normal curve is called mesokurtosis. A curve which is more peaked than the normal curve is called leptokurtotic. A curve in which flatter than the normal curve, which is called platykurtotic. I hope you understand the three different kurtosis. Just once again, I may highlight leptokurtosis as well as the platykurtosis. When the curve is more peaked than the normal one is called as a leptokurtic curve. If maximum in the distribution are considered around the mean, then the number of frequency falling between the -1 sigma to +1 sigma is more than the frequency falling within the range in case of normal probability curve. And the curve obtained for this distribution is called leptokurtic. The next one is called platykurtic. When the curve is more flattered, the distribution will call as platykurtic in X or not concentrate around the mean. Therefore, the number of frequency falling between -1 sigma to +1 sigma is lower in comparisons within the normal probability curve, and the curve drawn from the distribution is known as a platykurtic curve. But if you want to write a interpretation for the psychometric purpose, we can use this kind of conclusions or interpretations to lead the further analysis based on the parametric or non-parametric, based on the skewness value or the kurtosis value. We have to go further. Suppose a skewness and kurtosis value plus or minus 1 is considered very good for most psychometric users, but some cases, some of the authors or some of the book writers also highlighted they may use plus or minus 2 also. Normally the right skew value is greater than the +1, 0, +1. The normal probability curve, the skewness value is -1 to +1. If you go with left skewness, if the skewness value is less than the -1, we may come for the conclusion left skewness. The same way, the kurtosis value greater than 1 is called leptokurtosis. The mesokurtosis value is in between the -1 to +1. The platykurtosis value less than the -1. This is the way we have to write the interpretations when you do some psychometric purposes. So thank you so much. I hope you understand what is by descriptive statistics and its notations and its formulas too. Thank you. Bye. Jai Bharat.